Hello students. Today we will discuss about set transform. Okay. So in this we will see the region of convergence of discrete time signal. Okay. So here we have to find out the region of convergence for the given function. Okay. So before that I will summarize the region of convergence for the different cases. Okay. So we have already discussed about region of convergence. Okay. So what is region of convergence and all. Okay. So I don't want to again repeat the same things. Okay. So first we will summarize this table, right, with respect to region of convergence of discrete time signal. Okay. So first here we are considering three cases. First is a causal, non-causal and anti-causal, right? So what is causal sequence, non-causal sequence and anti-causal sequence? We have already discussed these things in the first chapter. Okay. So and again we will discuss the each case with respect to finite and infinite. Okay. See here, this is the finite sequence right sided. It is a causal function. Okay. So it is represented as a graphical. Okay. So in this graphical representation, so it shows the finite samples. Okay. It is a finite samples. Okay. So it is these samples are placed in the right hand sided. Okay. Or right sided. Okay. So sequence if the sequence exists in this format, then the region of convergence occupied entire z plane. This is the z plane. Okay, we know very well this one, right? This is the z plane. The x-axis is the real part, y-axis is the imaginary part, right? So we can also write this one as a real part of z. Okay, this is a imaginary part of z, right? So here the region of convergence occupy entire z plane except z is equal to 0. Okay, except z is, what is this? We will discuss while solving the problem how they are telling. So when the sequence is finite and if it occupies right sided, right, so then the region of such functions, the region of convergence is entire z plane except z is equal to 0, right? So I will show you, I will prove that by solving one problem. Okay. So next one is finite left sided. Okay, finite left sided sequence. If the sequence exists in the left sided, then it is a finite. Then graphical representation look like this. Okay. So then the region of convergence occupy entire z plane, but except z is equal to infinity. For z is equal to infinity, for the remaining value of z, okay, so it occupies entire z plane, right? So similarly for finite two-sided, okay, if it is finite right-sided means causal, right? Finite left-sided means anti-causal. Okay, if the sequence exists on both the side, right hand side and also left hand side, such type of sequence we call that one as non-causal. Then the region of convergence occupied entire z plane except z is equal to 0 and z is equal to infinity. This condition is very, very important. Similarly, right, so for infinite, right, for infinite sequence, if it occupies in the right hand side, right, see here, this is the representation of infinite, right? So this is right side, this is the left side, but here in the finite side, in the finite sequence, we have not represented like this, right? This is the finite samples. Okay, these are finite samples. These are finite samples. Okay, these are the infinite samples. Okay, in the infinite samples, okay, so if the samples occupied in the right hand side, we call that one as Gaussian, right? Then the region of convergence, right, it is outside the circle, right? The region of convergence occupied outside the unit circle or exterior of the radius r1, right? This is the magnitude that r1 indicates magnitude of circle, right? Or we can also tell that one as radius of the circle, okay, where the magnitude of z is greater than r1, which indicates, so the region of convergence occupied, okay, occupies exterior of the circle of radius r1, okay. If the sequence is infinite and it occupy in the left side, right? Left side, this is the graphical representation of anticausal, okay. Then the region of convergence, okay, occupied inside the unit, inside the circle of radius r2, okay, or magnitude of r2, okay. So the representation is, the mathematical representation of z is less than r2. It means the region of convergence occupies, right, inside the unit, inside the circle of radius r2. If it is greater than, means it occupies exterior of the circle. Okay. If the sequences are infinite and it occupies those samples occupied on both the side, both the right hand side, both the right hand left hand side, okay, then the region of convergence look like this here. So this is a causal. If it is right hand, means it is a causal. If the sequences or samples occupies in the left hand side, means it is anti-causal. If the samples occupies both the side, then it is a non-causal signal, okay. So in such a case, the how can we write that region of convergence, right? So here I have took r1 is a radius of circle of and r2 is the radius of circle, right? So this is the r1 is the magnitude of circle for the right hand side sequence, right? um, so sorry, r1 is, it is a less than, right? So r1 is the less than, right, magnitude of z, right? If it is less than r1, right, it is a left hand side sequence. The magnitude of z is greater than r2, right? It is a right hand side sequences, okay, or samples, okay. So here they are taking r1 is less than r2, then the first circle is r1, the second circle is r2, okay. So here, see here, the first one is the magnitude of z is greater than r1, right? The magnitude of z is greater than, then this is not correct, okay. This is r1, okay. The magnitude of z is greater than r1, right? It is a right hand sequence samples, okay. So then the region of convergence occupy outside the unit of radius r1 because the magnitude of z is greater than r1. Similarly, here in the left hand side samples, the samples occupied in the left hand side, it is infinite, then the magnitude of z is less than r2. Then the region of convergence occupied interior of the circle of magnitude r2 of radius r2, right? So the region of convergence region of convergence occupied or lies between the space of resistance R1 and R1 and R2. Okay. So this is the condition, right? So here the R1, here the R1 is less than Z, magnitude of Z, or we can also call it as the magnitude of Z is greater than R1, the magnitude of Z, right, is less than R2. In such condition, the region of convergence occupied or lies between the resistance R1, between the radius R1 and R2. Okay. Thank you very much. I think you are able to understand this concept. We will discuss some of the problems, right, based on this, right, in the next video. Thank you very much.